In this video, we're going to talk about more complicated triangle proofs. First, before we get started, let's remind ourselves what CPCTC stands for. CPCTC stands for corresponding parts of congruent triangles are congruent. For example, if these two triangles over here are congruent, then all of their corresponding parts, their corresponding sides, and their corresponding angles are also congruent because the whole triangles themselves are congruent to each other. For example, AB would be congruent to DE. Those are sides that are in the same spots on the two different triangles. BC would be congruent to EF. They are corresponding sides on the two triangles. And CA would be congruent to FD. For the angles, angle A would be congruent to angle D because they are corresponding angles. They are angles in the same spots on the two different triangles. Angle B would be congruent to angle E, and angle C would be congruent to angle F. Let's take a look at our given information for this proof. So our given information tells us that AB is congruent to CD. So I'm going to mark that in my diagram, which is always my first step for writing any proof, marking my diagram with the given information. I also know that BC is congruent to DA, so I'm going to mark that into my diagram as well. And I also know the shared side between the two triangles, so I can say that AC is congruent to itself, and that would be by the reflexive postulate. So taking a look at my proof statement, I want to prove that angle B is congruent to angle D. Angle B and angle D are in the same position, the same spots of the two different triangles. So angle B and angle D are corresponding angles of the triangles that they are in. I want to prove corresponding angles are congruent. I'm going to do that using CPCTC. And remember, before we can use CPCTC, we have to first know that the triangles themselves are congruent. If the two triangles are congruent, then all of the corresponding parts, the corresponding sides, and the corresponding angles are also congruent as well. So that's our plan. First, we're going to prove the triangle's congruent, and then we're going to use CPCTC to prove angle B congruent to angle D. I see from our given information and from the conclusions that we drew that we have side, side, side in the two triangles. So we're going to be proving the triangle's congruent using SSS. So take a second, pause the video, and try to write up the proof yourself. Remember, everything that is marked in the diagram that we need to prove SSS needs to end up in the proof. This was a short proof. Let's take a second and make sure that everything we needed for SSS actually ended up in our proof. So from our givens, we had two of the sides that we needed, AB congruent to CD, that was one of our S's for SSS, and AD congruent to BC. That was a second S for SSS. Our third S came from the reflexive postulate, the shared side, and there we have all the information that we need for SSS to make the triangle congruent. And after that, it's one more step to prove the corresponding angles congruent with CPCTC. Let's take a look at the next proof, and let's start off by reading the given information and marking the diagram. So AB and CD bisect each other at point E. Since they're bisecting each other, they are both getting bisected, which means cut into two congruent parts. So not only is AB getting cut into two congruent parts, but CD is also getting cut into two congruent parts since they are both bisecting each other. In part A, it says that we need to prove that angle C is congruent to angle D. If you notice, angle C and angle D are in the same spots in the two different triangles, so they are corresponding angles. We're going to ultimately prove that corresponding angles are congruent using CPCTC. But remember, before we can use CPCTC, we need to prove that the triangles are congruent. Once we know that the triangles are congruent to each other, then we know the corresponding angles are also congruent with CPCTC. So looking at the information I already have two pairs of congruent corresponding sides. I also see that I have intersecting lines. I see like a bow tie shape over here. My intersecting lines meet, to form congruent vertical angles. Anytime you have intersecting lines, vertical angles are formed. They look like they're across from each other, and they are always congruent to each other. So I see we're going to be proving the triangle's congruent with SAS, SAS. Second, pause the video and try to write up the first part of this proof. Let's make sure that everything that we needed to prove the triangle's congruent is in our proof. So from our givens, we had two pairs of congruent sides from knowing that DC and AB bisected each other. And if you take a look, that is in my diagram, but it is not in my proof. So if you did the same thing, that means that our S's were marked in the diagram, but they are not in our proof. So I'm going to take a second and update my proof. You should do as well. Keep in mind, anything that you mark in the diagram needs to end up in the proof. Okay, now my proof is updated to include the segments that were created by the bisector. So that's CE congruent to DE and AE congruent to BE. And my reason for that is a bisector cuts a line segment into two congruent parts. Notice how my reason for my vertical angles is a complete reason. I didn't just write vertical angles. Intersecting lines form congruent vertical angles. Then we have all of our information for SAS. We mentioned the angle, and we mentioned the two sides surrounding the angles. And then finally, once we have our triangles congruent, the corresponding angles are also congruent with CPCTC. Now we can move on to part B. Part B says to prove that line segment AC is parallel to line segment DB. Well, in our last step of the proof, we proved that angle C was congruent to angle D. And if we take a second, and let me get a different color here. So if we take a second and highlight the lines that we're trying to prove parallel and the transversal intersecting them, I see my letter Z is formed. And then the corners of that letter Z are angle C and angle D. They are alternate interior angles inside the lines on different sides of the transversal. If we have congruent alternate interior angles, then that means the lines forming them are parallel. Remember that showing that alternate interior angles are congruent is one way to prove lines are parallel. So that's just going to be one more step in my proof. Now that we've already shown angle C is congruent to angle D, we can now state that AC and DB are parallel to each other because of our congruent alternate interior angles. Notice how my reason is a complete reason. I didn't just write alternate interior angles. I wrote if alternate interior angles are congruent, then lines cut by a transversal are parallel. Finally, part C, if we know that angle C is 2x plus 7 and angle D is 3x minus 14, we can find x by setting these two angles equal to each other. We actually proved that they were congruent to each other. We know that they're congruent alternate interior angles, so if we set them equal to each other, we can take a second and we can solve for x. I'm going to subtract 2x from both sides, and I'm going to add 14. So here we have 21, and here I have x. So x is equal to 21. Let's take a look at this proof over here. So let's take a look at the given information. So we're told that segments AEC and BFC intersect at point C, and I can see that from the diagram. They definitely do meet at point C. I'm told that angle 1 is congruent to angle 2. CE is congruent to CF, and that EA is congruent to FB. And our goal is to ultimately prove that angle 3 is congruent to angle 4. So notice how angle 3 and angle 4 are in the same spots in the two triangles that they're in. That means that they're corresponding angles. So remember, in order to prove that corresponding angles are congruent, we're going to ultimately be using CPCTC. And before we can use CPCTC, we first need to prove that the triangles are congruent to each other. How we are going to do that. So I see a shared side between the two triangles, so I know that's going to be congruent to itself by the reflexive postulate. I see markings on this side of each of the triangles, And I also see that we have the congruent angles in between. So it looks like we are going to be using side angle side here. The only problem is that to use side angle side, we need the full side of one triangle congruent to the full side of another triangle. Right now, we know that this part CE of this side is congruent to CF and that EA is congruent to FB, but we don't have the full side CA congruent to the full side CB. But if we have the pieces, we can definitely put them together using the addition postulate. When we have information that's too small and we need to make it bigger, that sounds like the addition postulate. Now we have all of our pieces for SAS. Let's write them up in a proof, pause the video, and try to write it up as well. Okay, so let's make sure that we have everything in our proof needed for SAS. So from our givens, all we had was the pieces of the side, but we also had angle 1 and angle 2. So angle 1 and angle 2 were the angles that we were going to use for SAS. From the reflexive postulate, we had the shared side of the triangle CD congruent to itself, so that was one of the sides that we were using. So we mentioned one of our S's and our A's. We just need to get the other S's. And we said that we could combine the pieces to get the full side CA and CB using addition. So to make CA, we need to do CE plus EA. So that's over here, that part of the addition postulate. And notice how that makes CA. And to make CB, we need to combine CF and FB together to make the whole line segment CB. So that's our addition postulate. Since this plus this is this, and this plus this is this, we are substituting the addition with what it actually is. So that's the substitution postulate. Now we have the two triangles congruent by side, angle, side, side, angle, side. So once the triangles are congruent, we know that their corresponding angles 3 and 4 are also congruent due to CPCTC. Okay, here once again, we're going to mark the diagram. So we know that DC is congruent to DE. We know that angle X is congruent to angle Y. And we also know that angle Z is congruent to angle W. And our goal is to prove that AE is congruent to AC. So AE is right over here, and AC is right over here. So I see that AE is a side of this larger triangle over here, and AC is a side of this larger triangle over here. So ultimately, to prove that AE is congruent to AC, we're going to use CPCTC. And before we can do that, we do need to prove these two large yellow triangles are congruent to each other. I do see that triangles ACD and AED share side AD. So that is congruent to itself by the reflexive postulate. And I do see that to start off with, we had another pair of congruent sides, and we have some information about the angles in between. So that looks like it's going to be side, angle, side, side, angle, side. The only problem is right now we don't have this full angle. We have the two pieces. And over here, we don't have this full angle. We have the two pieces. So just like in our last example, we're going to have to combine the pieces together with addition to get this full angle ADE and this full angle CDA. So let's pause the video and write up our proof. Please do the same, and then you can check it out. Okay, let's check our proof. So from our givens, we have the first S, DC, and DE. Then we have our second X, the second S, the second side, the shared side, using the reflexive postulate. And then to get the whole angles in between, we did need to use the addition postulate. Angle W plus angle Y makes angle ADE, and angle Z plus angle X makes the larger angle here, angle CDA, that we need. Then we have SAS, and once the triangles are congruent, side AE and AC, those are corresponding sides of the two triangles, so they are congruent by CPCTC. Here we have overlapping triangles. So two strategies for working with overlapping triangles are to color code the different triangles and to separate the triangles and draw them separately. So I'll start off with color coding the two triangles. So I'm going to highlight one of the triangles in a different color. so that they are two different colors from each other. I'm going to mark the diagram with my given information. So DA is perpendicular to AB. That means they form right angles where they intersect. CB is perpendicular to BA. Once again, that means they form right angles where they meet. And we also know that angle CAB, A is in the middle, so it's here, is congruent to angle DBA. B is in the middle, so it's right over here. It's still a little bit hard to see what's going on, so I am going to draw the two triangles separately. So I'm going to draw my yellow triangle over here, and I'm going to draw my black triangle right over here. So my yellow triangle is DBA, and my black triangle is CBA. And I'm going to mark the diagram with what we already had so that we can just see it more clearly. And look, now it's a lot more clear that we already have two pairs of congruent angles in the two triangles. I also now can clearly see that there is a shared side between the two triangles. When triangles overlap, there's always going to be either side or an angle that is shared between them. So look out for that. Look out for your reflexive postulate. I see here that AB and AB are the same side. They have the same letters. And in the diagram, they definitely are the same side. So I'm going to mark those as congruent to each other by the reflexive postulate. And now I see that my triangles are congruent by ASA. And once I have my triangles congruent by ASA, it is one more step to say that the corresponding angles D and C are congruent by CPCTC. I'm going to take a second and write up the proof. Please do the same as well. And here we have it. Notice how everything that's marked in the diagram ended up in the proof. From the givens, we do have perpendicular lines, but we do have to state that those perpendicular lines make right angles. And then after that, since we are using ASA, which has two pairs of congruent corresponding angles, we do need to also state that the right angles are congruent to each other for that pair of angles for ASA. And from our givens, we have our second pair of angles that we're using, angle DBA and angle CAB. And then our reflexive postulate gives us that side in between. So there we have all our information for ASA. Then it's one more step after that to prove the corresponding angles congruent by CPCTC. Okay, this one's a little bit different. So we have that AC is congruent to AD. We have that BC is congruent to BD. And we see that AB intersects CD at point E. Nothing about bisecting. Let's not make things up that are not here. So no bisector, just intersects CD at point E. And our goal is to prove that angle 1 is congruent to angle 2. So angle 1 is inside this small triangle here, and angle 2 is inside this small triangle here. So if I want to use CPCTC to prove these two corresponding angles congruent, first I have to prove these two yellow triangles congruent. But looking at these two yellow triangles, okay, I have one pair of sides from the givens, and I have this shared side here, EA, so that's reflective postulate, but that's all I have. I have two S's. And SS is not one of our ways of proving triangles congruent. The right way at the start here, I don't have enough information to prove those two triangles congruent. But I do have enough information to prove another two pairs of triangles congruent here. Can you find two triangles here that we can prove congruent? And feel free to pause the video so that you can take a look. If you take a look, oops, I'm a bad highlighter, at these two larger triangles, triangles BCA and triangles BDA, notice that we have two pairs of congruent corresponding sides from the givens. And we also have a shared side BA, which is congruent to itself by the reflexive postulate. Now, if we can prove these two bigger triangles congruent, and that would be by side, 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 then once we know that the two blue triangles are congruent, we can use CPCTC to get more information about the two yellow triangles that we want. So if I prove the two blue triangles congruent by SSS, then it would really be helpful to me since I already have two pairs of sides in the yellow triangles to get the angle in between. Because if I got the angle in between, then I would have side, angle, side, side, angle, side, and I would know that the two yellow triangles that I actually want are congruent with each other. And that works out perfectly because these two angles, not only are they in the yellow triangles that I'm interested in, but they're also corresponding angles of the two blue triangles that I can prove congruent. Our plan, prove the two blue triangles congruent, then use CPCTC to get these two angles that we need, and then from there, we'll have enough information to prove the two yellow triangles congruent. And once the yellow triangles are congruent, CPCTC will get us angle 1 and angle 2, which is what we need. Pause the video, try the write up the proof, and then you can check it with mine. Okay, let's make sure that we have everything that we need in this proof. So first, we have the information to prove the two big blue triangles congruent. Two pairs of the sides came from the givens. So that was one S, and here was another S from the givens. And then our third S was the shared side of the big triangles. It's BA, congruent to itself by the reflexive postulate. So we have our three S's for SSS to prove the two big blue triangles congruent. Now, once we know those two blue triangles are congruent, then angle CAE is congruent to angle DAE by CPCTC, and that gives us the angle that we need for SAS in the two smaller triangles. So our givens gave us one of those sides, so I'll put it in a different color. That was AC and DA, so we need that for the other two triangles as well. And then from CPCTC, we got the angles in those triangles that we need. And then the other side is the shared side, which is EA congruent to itself. So there we have the side, angle, side to prove the two yellow triangles congruent by SAS. And then once we know the two yellow triangles are congruent, we know that their corresponding angles 1 and 2 are congruent by CPCTC. There we have it. Sometimes the triangles that you're interested in, you won't be able to prove congruent right away. So you'll have to prove a different pair of triangles congruent so that you can use CPCTC to get more information about the triangles that you're actually interested